Let's go through LeetCode 1038, binary search tree to greater sum tree. For this question, give us a binary search tree. And let's do the operations that each key of the original binary search tree is changed to the original key plus the sum of the all keys greater than the original key in the binary search tree. You see that all the values in the tree are unique. So we'll say, let's look at the example, right? So for example, 1, right? We'll add all those kind of nodes value which is greater. For example, 2, 3, 4, 6, 5, 7, 8, right? So the things that we will say greater than, because they are distinct. That means if we use a in-order traverse, all of the nodes on the right to the current nodes, right? After we do the in-order traversal, we'll see those kind of binary search tree, those kind of nodes are in orders, right? So all of the nodes after itself will be greater than the nodes, right? So intuitively, what's thinking about is that possibly we can you traverse once, get all the sum, right? And then we do in order traversal that we may use a pre-value, right? Pre-value initially set as 0, and then for every we do the in order traversal, and for every node it use a total sum, right, minus pre, and then after we traverse to the next one, right, and then update our pre to add to current value, right? So intuitively, that is we traverse once to get us a sum, right, and traverse twice the second time to update every value to use the sum minus pre, right, and then update to the pre. But the thing is that we can do something better. That is, if we look at this value, right, it is itself, because there is no nodes greater than 8, so it is itself. But for these nodes, it is 7 plus 8, right? And for this node, it's 6 plus this, right? And then this one will be 5 plus this, right? So what we know that in order traversal. So can we do something reversely, like in a reversed order of in order traversal? I think in that case, we can do just a traverse once, right? So how can we do that? We know for the in order traversal, we have 2 ways. One is using the like the DFS way, recursive the recursive code, right? Another way is we can use a stack, right? So we can use a stack for this kind of question. That normally when we do stack, we do the in order traversal is that we push every node to its left, right, until there is no nodes, and then move to the right, right? But for this one, if we do reversely, we just push everything to its right until there is no nodes, and then do while go to its left, right? So that we just need to traverse once. Then let's begin to write code for this. So we know we need a stack. We'll have a sum, right? Because every time we traverse, we'll update this sum, and also our result will our every node's value will add equal to sum. Okay. So we are going to have stack tree node stack equals new stack. Okay. and say while this root doesn't stack is not null. It's not empty, right? Or this node root unequal to null. Then let's say while this kind of root unequal to null. So we are going to have a stack push root dot right, right? And our root equals root dot right. And when we jump in this out of this while loop is we're going to have root equals here is the thing we can do this because we want to return the root in the end, right? So let's have set it current tree node current equals to root, while current does not equal to null, right? Use current as a cursor. Current dot right, current dot right, right? And the current equals stack dot pop. And then we do something here, right? Do something here. Then current equals current dot left. And then in the end, we just return root, right? We use another variable because we don't we want to still return root, right? So what we do is that we are going to have do something sum plus equal to current dot value and set current dot value equals to sum, right? Like dot pop and current is now current equals to root. This is a push current, right? This is doing like this, the time complexity will be O(n), right? And also we just need to traverse one time. There is we do not need to traverse twice, right? Python code should be similar, right? So we need to have a sum variable and to, for example, sum variable and a stack variable, right? We call total, right? And we have a current, right? So total will initially set as 0, stack will be this, right? And current equals root. So what we do is that while stack is not empty or current is not empty, right? So it's not while current. So we'll have stack append current, and we'll have current if current dot right, right? So after jumping out of this while loop, we'll have current equals stack dot pop, and we'll have sum plus equal to, not sum, we call total, right? Plus equal to current dot value, and then we'll have current dot value equals total, and then we'll have current equals current dot left, just then we are going to return root.